Good afternoon, everybody. We are with you on the third day of Zero Build Turkey 2021 with the fourth session of ZEB Day. My name is Pınar, Yalman, Akcengiz. I'm the board member of ZEB Zero Energy and Passivhaus Association. Today, with our two speakers, we are planning to have informative and enjoyable sessions with you. Our session will be in both Turkish and English. Now, I would like to introduce actually speakers with you, Dr. Francesco Nese, CEO of ZEPHIR Passivhaus Italy, and Seda Güleç, head of BoardModerator. Today, we had the opportunity to see in detail examples with the case studies from many different countries regarding passive houses, with the sessions carried out from morning till now. Those case studies are passive house certified houses and schools. So in the sessions, we will listen presentations about passive house certified public buildings. Before starting the presentations, I would like to give some information about our speakers. Our first speaker is Seda. Seda Müftüoğlu Güleç is an architect, green building expert, and certified passive house designer. She graduated from the Faculty of Architecture in 2008. After completing her master's degree on ecological architecture in 2010, then she started to work in Gaziantep Metropolitan Municipality in same year as the Ecological City Project Coordinator. It belongs to Gaziantep Metropolitan Municipality in 2013 under the coordination of Seda, with LEED Platinum, and Turkey's first passive house certified green building project has been implemented and has been awarded up to 6 different branches today. In the ecological building, seminars and applied trainings on energy efficiency, environmentally sensitive structures, and renewable energy are organized for many people. Seda, who has been a passive house designer certified by the Passivhaus Institute of Germany since 2015, is still working as the zoning manager of Gaziantep Metropolitan Municipality. At the same time, she gives lectures on ecological architecture in the architecture departments of various universities and is assigned to consultancy services on passive house to various ministries, public institutions, and organizations. And finally, she is head of the board of ZEPEV since 2019. So yes, briefly, Seda, so the floor is yours.
Çok teşekkür ederim. Umarım
Thanks a lot.
Bugün güzel bir gün geçiriyoruz.
We are having a fruitful day. I'm extremely pleased to have all these panelists here and listen to all these colleagues, and we have some key words, and it is important for my organization today. I will make 2 presentations, and my presentations cover public buildings, and these 2 buildings are in Gaziantep. The first one is renovation, and the second example will be the new energy. And first I will talk about the renovation building, and then I will move to the new building. Let me share my screen with you. Just a second. She is trying to open the presentation. Can you see my screen? Yes, we see it. The first building that I'm going to talk about is GAP UNDP building. It is the Incubation Center project. In this project, they need a common office for the specialist, and the former and the current status of the building can be seen here. In the first part, our building, as I said, it was a bank. And then the organized industrial zone owned this building and then was serving this. And you see the former situation of the building, and it was not used. Let me give you some information about Gaziantep. It is located in the southeastern part of Turkey, and its summer is hot and it is cold in winter. It is rainy and full of snow. But when we look at the balance between summer and winter, we consume energy for cooling purposes. And in this respect, the cooling workload is too high. And you see the former versions of the building. As you see, the building suffered from moisture, and there were some parts which were not used, and it was not used actively. In fact, although they had a Turkish way of stopping cold air leaks, and we conducted an analysis. It has three main parts, and then we worked on the air tightness of all these parts. And following the analysis, we realized that the condition was poor. It was not enough, and we completed a new design in line with the NLP standards, and we completed the projects, and we presented in 3D version. Since it is a location and of hot weather conditions in summer, first we worked on thermal acoustic insulation and air tightness and best windows and doors. I will show all these stages one by one in the course of my presentation. And we used this window framework and also window frames and also door frames for us. And in order to reduce the workload for cooling purposes, we carried out some controls, and also for natural ventilation, and also in order to reduce the workload for cooling purposes, we decided to design it with windows that can be opened, especially at night times. And also we had this heat recovery, and natural ventilation was important for us, and ventilation with cooling, sometimes dehumidification. You see the plan, it has 300 square meters. It is an open office design. Let me highlight one detail, the insulation part from the outer and interior wall. It has a good insulation, and all walls and also windows have good membrane examples, which I will show you. The devil is in the details, as the slide says. So for us, this passive house and building these type of buildings are important in details, and it is really good for us. We can design it in a good way, but we need to improve the awareness, raise the awareness of all these issues. If you were not with us in the morning session while I was talking about this issue, in the morning session, we as ZEPHIR work with designers and also artisans, and we also serve as a training center. First of all, the building was poor in terms of its windows and also its doors, so we removed them, and then we began working in the interior part because the moisture and there were some walls that need to be removed, and we changed the roof completely. it was highly problematic since it was the renovation projects. That means we didn't have any chance to work on the basement, but we did our best to enhance the water insulation and also drainage system. Although we were not able to reach the basement, we did our best to support the insulation, and we used this material which has 15 centimeter thickness. You can see the outer wall, exterior wall, and you can see the insulation materials here. As you see, the material in fact is important for the humidity and to serve as a barrier to humidity. And it is stone wool and also glass wool, which are very important for us. And it is important for heat tightness, and also it is important, these membranes are important for us. And we have this stone wool. Following the interior part, we have these windows which are certified, which are in line with the standards. As I said before, we have this insulation and these triple glazed PHI certified PVC windows, and we have used also PHI certified MVHR units, and we also use the pump, air source heat pump, and we have PV panels roof, which is 6 kilowatt, and we also use air tightness membrane and tapes. Of course, we use the insulation materials to make the house passive house. When we analyze this energy in a general way, the payback period and also the saving parts, what we see that before the renovation and after the renovation, we see that the space heating was 143 and it became 19, and space cooling was 180 and it became 28, and fans, pumps, and electricity use was 65 and it became 53. In total, it was 388 and it became 100. So the heating savings was about 85%, and in total, it is up to 75% reduction in overall energy demand. And the budget of the project was $130,000, but as a result of extra materials, the budgets increased up to 190,000. When I asked the reason, they said it was a harsh winter and they had to wait, and there were some delays, unexpected delays, unforeseen delays, and because of the delays, some materials were deformed, so there was an extra cost, an additional cost. When the winter was over, and due to the limited time, they completed the construction in 3 months. So they had to replace these materials which were deformed, and they had to finish the building in a very short period. That might be the reason why there was this increase in the project budget. The project was completed and the building was opened in 2016. The then Minister of Development was there. The Mayor of Gaziantep Metropolitan Municipality attended the ceremony, and I was there as well, and it was a very nice building. We were proud of it. and we are proud of it. And following the completion of the issue, following the completion of the project, you can see the buildings. I also would like to say that this contraction 2021 and this building became the world champion. So in this renovation 2021 category, and I'm extremely pleased. So that's all from my presentation. So that's all from my side for this session, for this presentation.
I think example for Turkey's condition, because Gaziantep is the leading city for many projects. So this is very important for our country, as the first example for public buildings. So thank you for your presentation again. We will go on. So our next speaker is Francesco Nese from Italy. I'd like to give some information about him. Francesco Nese is a building physicist and Passivhaus trainer, designer, and certifier, and the CEO of the Italian IFA affiliate, ZEPHIR Passivhaus Italy. His throughout the Mediterranean and in many countries in the world, besides Italy, of course. His main activity is offering consultancy to developers and private persons who aim at getting a cost-optimal buildings. Training for professionals and construction companies is also another important task of his institute. He wrote a book, Passivhaus, which sold more than 4,000 copies in Italy. In the recent years, Francesco has been offering consultancy and support to developing countries like Cameroon and Bhutan, where the new building standards has been finally defined thanks to his work on this field. So the floor is yours, Francesco.
Thank you very much for the very nice presentation. And thank you for inviting me. I'm very happy that I can contribute to this great movement, both in our respective countries, in Italy, in Greece, in Turkey, and so on. So we are all one big country, so to say, in the Mediterranean, which share similar climatic conditions, seismic effects, and so on. And that's why it's very important that we can share our mutual experiences in our respective countries. So I'm gonna show my presentation. Let me see if I choose the right one. Okay, can you see it?
Yes.
Okay, perfect. So, hello everybody. It is a great pleasure for me to be here speaking about one of the greatest Passivhaus projects in Italy so far. This is an office building which required a very big expertise in order to bring it up to the Passivhaus level. As we already saw in the past session, in the previous session, when we showed the school examples, this is which didn't start in the proper way, but it required a big expertise how to act on the single details and so on. As Seda said before, the devil is in the details exactly. So we did the same in this very project. So as you will see in the following, big challenges had to be overcome, but our aim of realizing a cost-effective Passivhaus building was in fact finally met. The project is located in the Marche region, in a location pretty close to the Adriatic coast, as you can see here in these pictures. The orange spot here shows where the building had to be realized. It consists of a cardboard box factory, that's the reason for the name MEGABOX, and an adjacent office building, which is the one to be designed with the Passivhaus standard. This is the one which you see here in front. As you may see here from above, the office building is indeed a very challenging project since it only faces north, as you can see here in the map there. And for sure, it was not an easy task to optimize it in order to finally hit the Passivhaus standard. Only a limited amount of solar gains can be provided to the building. And besides that, several balconies on the northern facade made the task even more challenging, not only shading the already limited diffuse radiation, but also introducing some major thermal bridges to be solved in a smart and cheap way. I speak about cheap because for this project and in our consultancy in general, the economic viability is always the driver of all the choices, provided that there are no comfort or hygienic issues, of course. Closer look to the final project. The Passivhaus office building is completely shaded on the other cardinal points by the neighboring factory. Here you can see the floor plans, the first and the ground floor. After looking to the project more closely, we could make it even more compact, even though it shows a quite unfavorable form factor. It consists of several office rooms, as you can see here, a couple of meeting rooms in these wings, some storage room, and the lift. As far as the building assemblies are concerned, we can see that the U values are quite unusual for this warm temperate climate. I would have expected something like 0.25 or 0.2 at least, but they are very low if you really closely look at the climatic situation. The extra costs needed to install a thicker thermal insulation nevertheless paid back completely and somehow compensated the missing solar gains. No solar gains, extra insulation, no way. The load-bearing structure is made of CLT, so wooden structure, and the wide use of airtight membranes was made in order to achieve very low values of N50, touching even 0.22. This is the detail, for instance, for the joint between external wall and floor slab. No basement is present, so it's pretty easy to be solved. Thermal bridge free, almost. This is a similar detail with the window installation. Due to the fact that the load-bearing structure is made of wood, cross-laminated timber, CLT, it was simpler to fit the window behind and not in the thermal insulation layer. And nevertheless, the thermal bridge still remains quite small and made the installation very simple also for the tradespersons involved in the construction, which also in this case had not so much skill to approach such a Passivhaus project. This is another detail related to the joint external wall to Actic. As you can see, the thermal bridge of the parapet is almost negligible. All supply and exhaust air ducts are placed within the plasterboard ceiling so that air is supplied and extracted just below the ceiling. This allows a good circulation of air regardless of the position of the interior furnishings. MEGABOX office building includes 2 meeting rooms, with a completely different pattern of use if compared to the other office room of the building. To reduce investment costs and keep maintenance costs low, a centralized unit with variable air volume, a VAV, was chosen in order to guarantee the suitable airflow rate when needed in each room. The needed airflow is around 450 to 500 cubic meters per hour. Heating and cooling will be provided by an air-to-air heat pump. So there is only one device with a very simple distribution duct system that simplifies everything, both in terms of technical aspects as well as on the economic viability. Both heat pump and server room are located outside the building in the neighboring factory in order to get rid of unuseful overheating in summer, noises, and enhanced thermal losses due to an increased airflow rate. In summer, even though this is facing north, when the sun shines, the radiation may be really high. A ducted split unit provides a cooling boost through recirculation of air inside the building, thus keeping the mechanical services pretty simple. And when people are present in the meeting rooms, an extra and dedicated ventilation can be provided, especially for that rooms only. Let's come to the construction phase. Here you can see the execution works have been done properly. Here you can see the airtight layer and the use of these special airtight collars. On the right-hand side, very high quality Passivhaus certified windows with a class of efficiency PHA and the very well done window installation made it possible to maximize the solar gains whenever possible, as far as possible, because it was facing north, while keeping the thermal losses through them pretty low. Here you can see that the window frame is completely covered by the external thermal insulation layer, which results in a very low installation thermal bridge. And here you can see also in the ventilation unit, as well as the insulation of the domestic hot water pipes and so on, and the distribution behind the below the ceiling of the single valves and ducts and so on. On the roof, 200 kilowatt peak photovoltaic system has been installed in order to supply both the office as well as the neighboring factory. This is how the final office building looks like after a ventilated facade has been installed on the outer surface of the building. And this kind of columns resembles a lot trees, and with these decorations on the facade, the effect, especially at night, can be really interesting, thus showing off how sustainable this cardboard box factory can be. Finally, this certificate was issued around a couple of years ago, and here you can see the amazing figures we could be able to get. Amazingly, it's amazing if you think that we had to face dramatic challenges like facing north, a lot of thermal bridges, and shading by the neighboring factory building and so on. The certificate was issued especially during a special ceremony where the mayor, as you can see here, was also present and could appreciate the quality and the significance of this building for the region. And this is in the center, in the middle, this is the MEGABOX owner. But how did we get to this amazing result? Let's sketch it and let's analyze it really step by step. Starting from the initial sketch, and as I said in the beginning, it was not born as a Passivhaus, but it was brought step by step. Also, letting engage all the stakeholders, the owner, the architect, and so on, and the mechanical engineer together in order that we, within an integrated design, could get to this final result. So in the beginning, starting from this original sketch, the PHPP, the Passivhaus software, showed a not surprising 37 kilowatt hours per square meter year for the heating demand. After working a little bit with the windows, by reducing their number and their size, we could get further down. And then in the third picture, you can see the width of the windows were extremely reduced because only diffuse radiation come actually from north or a little bit lateral in summer, but not so much. But it was not yet the final story, because the final steps to reach the Passivhaus standard were making the thermal envelope even more compact by moving one volume from the first floor to the ground floor, thus increasing the compactness of the building, and using triple panes, low glazing units with a very energy efficient window and window frame in the Passivhaus class of efficiency, Passivhaus A, PHA. This allowed us to even remove the roof windows, which constituted a very expensive component at the moment, the extra cost for the better windows being more than recovered by removing the roof windows. As you see, we used again the principle of the cost effectiveness as a driver of our choices. PHI Passivhaus Institute already partially implemented the economic viability in PHPP 9, but our company made some improvements on the calculation, which follows the norm EN 15459. In this slide, I want to show you the comparison between three variants if related to the minimum energy standard. The first one is the market standard, so which means what is usually done here in Italy. The second one is the ZEB, as you see here, the violet one, according to the Italian definition, and then the Passivhaus standard in blue. You can see that if one chooses Passivhaus already in the first year, here you can see a zoom of the first and the second year, the lowest, the better, which means you gain, even the lower, the better you gain money compared to the zero level, which is more or less what is done usually in the market. So already in the first year, Passivhaus lies below all other curves, which means you save money already in the first year. Again, as it's been said several times, if you do it well, as Wolfgang Feist always says. And I would add, even upon the worst boundary conditions, like in this case. I'm approaching to the end of my presentation. I just leave you these words given to us by the factory owner, Ivano Angeli, and we can read it together. So he says, pleasant and comfortable for those who work there, because while working, everybody must live in a healthy environment. We want to be an example for other companies and for the whole community in that region. So we even interviewed the house owner, and I would suggest to the organizers to share the video, which is in our YouTube channel, and which also includes some subtitles in English, of course. Thank you for sharing it.
Passivhaus, perché comunque penso che sia il massimo del costruire in una tematica di ambiente. Ecco. Passivhaus era una volontà mia soprattutto di fare un edificio confortevole, basso consumo, basso impatto ambientale, perché volevo, come ho detto prima, lasciare un segno importante nella comunità, nella mia vita. Noi produciamo imballaggi in cartone ondulato, quindi è uno dei materiali che nell'imballaggio è il più adatto per un riciclo, per materie prime vergini, per far sì che non vengano usati altre materie prime.
Come è scaldata questo ufficio o come è raffrescato?
Qui abbiamo la cosa più importante è l'isolamento, che fa la differenza, perché comunque l'isolamento non ti crea questi sbalzi notevoli che in casa uno può avere. Quindi con poco uno diminuisce la temperatura o eleva la temperatura, che in casa non hanno mai questa particolarità di essere elastiche come qui dentro. Le esperienze prima di queste erano fatte con il sistema tradizionale che ci sono sul mercato finora. Ecco, quindi la casa che ho fatto rispecchia gli standard normali che tutti i progettisti fanno, con una climatizzazione, pompa di calore, però riscaldamento pavimento, sì, però coibentazione poca. Infatti vivendo qui in questo momento vedo però ci sono una grossa differenza di qualità della vita. Non ho mai sentito nessuno lamentarsi che è troppo caldo, che è troppo freddo o che c'è un'aria insopportabile. Anche negli ultimi periodi che abbiamo avuto il lockdown siamo venuti a lavorare e comunque non abbiamo tenuto la climatizzazione accesa. Siamo stati con le finestre chiuse, ma comunque si viveva bene. Ecco. Non ci sono sbalzi di temperature, o correnti d'aria, finestre aperte.
Esatto.
Sicuramente questo incide molto per i malanni di stagione, queste cose qui.
Il discorso del riscaldamento è anche a livello di rumore, cioè comunque si sente sempre una ventola, si sente sempre qualcosa che può dare fastidio. Io dove ero nell'ufficio precedente avevo proprio la ventola sopra e quel rumore a lungo andare, soprattutto quando si deve lavorare alla scrivania, è veramente fastidioso, perché a un certo punto sembra che non te ne accorgi più, ma non è vero, cioè, è come un accaldamento continuo. Invece qui non abbiamo rumori, non ci sono rumori dati dagli impianti, e anche questo qui sinceramente è molto più rilassante. Nella zona di là dove lavoriamo tutti insieme, anche la vetrata che dà la visuale fuori, e la luce del giorno cerchiamo di utilizzare il più possibile, per cui anche questo crea un ambiente rilassante. E quando si lavora molto tempo al computer vuol dire qualcosa. Sì, sì.
Anche l'odore è una cosa caratteristica, l'odore del legno. Magari stanno tutti i giorni non ci se ne accorge, ma basta fare una settimana di ferie, quando si rientra qui già c'è un'aria che non è quella dello smog dell'esterno, è proprio un'aria di pulita, di legno, ma è appena percettibile, ma si sente.
Quindi, diciamo, se dovessi stilare un bilancio su questo tuo investimento, lo proporresti ancora? Lo rifaresti?
Io lo consiglierei vivamente a chi crede nell'ambiente, ma soprattutto una qualità della vita migliore che quella che in questo momento sta facendo. Perché uno ricerca una qualità di vita soddisfacente, migliorativa, sicuramente nell'edificio Passivhaus è qualcosa di fondamentale.
Insomma, questo toscano non te l'ha venduta, insomma, solo sulla carta.
Questa volta mi sono sbagliato io.
Dai,
sui toscani.
Grande. Quindi grazie ancora di aver realizzato questo edificio per noi, per la comunità, per tutto il movimento Passivhaus, chi ha a cuore l'ambiente.
Spero che sia ad esempio per altri imprenditori e non solo come me che hanno voluto fare questa sfida.
Complimenti ancora.
Grazie.
Grazie.
Francesco, it's a great job. It is really nice to hear that their satisfaction from the users. Environment is very important, of course, but from the entrepreneur side, the cost-effective investment is the most important thing. So it is very nice to hear the implementations and the gains. So congrats again. I will ask the questions after Seda's presentation. Thank you again. And Seda, the floor is yours again.
Evet, tekrar merhabalar. Umarım şimdi
once again, hi.
Sunumumu açabileceğim.
I hope I'll be able to share my presentation. Sorun var mı? I presented this presentation before, as we are living inside this. This 101, and I am living in this building, the construction phases and the final construction phase. So I'm sharing this with great enthusiasm, and of course there will be passive houses in the other buildings. We would like to show example. So why there is such a building? Why in 2011 there was such an idea in Gaziantep Metropolitan Municipality. Gaziantep Metropolitan Municipality prepared the first climate action plan in Turkey for decrease of carbon dioxide emission, and also cover the climate change effects to decrease the energy spendings. It's a part of a larger project, actually, and when we look at in larger scale, the climate action plan has different pillars: transportation, industry, and also buildings and cities and services sector. Actually, with the buildings, at the stage of what we can do regarding the buildings. So a huge area in 32 million square meters of land, we prepared an ecological city. When you look at an X-ray of Gaziantep regarding the climate, we have a huge industry. We have 5th industrial zone. However, the energy in the buildings is more than the energy in the industry. When we look at Turkey, in Turkey, 32% is between in the buildings, and 32% is within the buildings. So we have a huge migration. There are there are some buildings which are not sensitive to climate. So rather than making up a makeup, and we do not take into account the energy efficiency. So as metropolitan municipality, in order to prevent the effects of climate change, we plan an ecological, Gaziantep ecological plan with 32 million square meters. I like this picture a lot and I share it all the time because it is about, this is a very good picture of why we have opened this place for a master plan. For you can see there are different buildings and it's affected by the collective housing pressure. So please do not forget this. We have all the green areas, all the recreation areas are preserved, and also, as I show you in the visual, as this is a valley effect is there, so no one cuts the other's sun or wind, and there is a very good structuring. Of course, planning was made so that all buildings could benefit equally from the sun and the wind. As you can see, just a second. In this area, as you can see, this is the construction that we hope. Maybe the envelopes can or the facades may not be similar to that. However, where there is the valley, there will be low intensive, and when you go higher, there will be higher intensity. When I say high intensity, maximum 8 floors. Story building will be conducted, and except for this, and the green areas will be used as gardens, and they will be preserved this way. There will be 150 square meters. The house can be constructed there. We can continue. So when we look at the Gaziantep ecological city, that we are talking about the year of 2011, this was no one understood what ecology is. Everyone thought that this is a spaceship. So we wanted to have an exemplary building for that. Of course, we do not expect all the buildings that should be there. That should be a service building, and for the energy efficient buildings and green buildings and renewable energy. This is an information center. So while we are turning it to an ecological structure, we also looked at the building types in the world. What we liked most, what we trusted the most was the passive houses. And we said that can we adopt this passive house into Turkey? Can we do that? And we communicated with the consultants. Tuba Hanım is the first passive house certified person in Turkey. And we made a project, and through that we discussed what we can do in order to have this as a passive house. And there were some changes in there, and then we were successful, and this is the highest elite certificate. As we can see, this is the highest number, highest score building. We started in July 2012, and the completion date is February 2014. Let's continue. We have the Passivhaus certification. We received both of the certificates in 2015, and we have the LEED Platinum certificate. There is a 315 square meters. There is a 60 conference hall for 60 people, and we have a foyer area. And in this project was for 113 people. However, as the building grew, the operational cost will grow, and we had some meetings regarding that, large scope meetings regarding that. I always say one thing, this is, we cannot compare it with a residential building. And of course, as the stakeholders know, in the ventilation system, there is a per capita ventilation system, and there is a certain sublimit, and this is how we select our buildings. And this is we made the calculations thinking that there are 75 people in the building. Here we are talking about the 70 people of 75 people, and there are different mechanical equipment, and we implement it accordingly. And let's continue. This is the LEED scores that we received. It's a list of scores that we received, and I think that it's very good when we received it. Like it is the case, you know, in all the criteria we received good scores, and I will tell you where we received the scores. So we wanted to have a Passivhaus. There is a 75% of energy saving that we have made, and the energy efficiency could be increased up to 90%. So there needs to be a better insulation. The tightness measures will be taken, and also with the equipment, they should be energy saving equipment. We will pay attention to all these. And we wanted to support our building with photo building, and let's make it a nearly zero energy building, or let's have a zero energy building. However, as you can see, as what we observed is that it's a plus energy. It's not a zero energy. It's a plus energy building. So we can say that the energy it produces more energy than it consumes. So we can say that 30,000 kilowatt energy is produced, and 22,000 kilowatts is consumed. So we can say that there is a surplus of energy generation. And in addition to that, when we look at this, there is an extra gain that we can take from it. And there is a 1.6 million installed power, and there are 84 panels that we have photovoltaics, PH, and the photovoltaics could be on the roof or could be on the facade of the building. But I'm showing the photovoltaics because this is within a green area, and you can see the high trees there. There is because of the shading risks, we didn't put them there, and we realized this building in 2012, and in its photovoltaic systems wasn't that in use back then, and there are residences, and this is for the people who are in there, people thinking that I can do that. We wanted to show them there. That's why we are positioned in the garden. There is with the sustainable city scale, the building if you know from LEED, we received a high score because on foot and with public transportation, you can go there. People don't have to drive and don't have to go to a different part of the city to see that building. And it is within the Atatürk 100. Yıl Culture Park. It is positioned with it, and and the door is open for everyone, especially in terms of a function. There is also promotion and information activity so that people can enter inside easily, and they can make it the system. And I think that this could be there. It's in a location that people can easily have access to. In the beginning of my presentation, we gathered together with the Passivhaus consultant. In our architecture with a concept sketch, there was a more of a different building, but it doesn't mean that passive houses can be in the compact architectural design. There are different typologies of buildings with different functions of the buildings. So in all the conferences, in our sessions, we always try to understand, explain one thing. The passive houses can be applied to all the functions, all the different typologies of buildings in order to dispose the risks. We wanted to have a more compact architectural design. When I go to university, I say to my students, fly away with your design. But all of this, all the corner points, and in the adherence points where different materials are gathered, there could be problems with the tightness, and you have to take the measures regarding that. So as we have a more compact architectural design, for example, we use the air tightness membranes, and it's a compact design, and also there's the air tightness membrane that can be used. Let's continue. So when we look at the standards, when we look at the TurkeySEPEV's values, we look at the U values, and the U values were compared. Comparison of thermal insulation standards in buildings and provincial ecological building thermal insulation values were made. I wanted to show you this table. And we can say that there is 35 centimeters long insulation in the roof, and in the foundation there is a 30%. We used the blown glass, and we use XPS there, and at the same time, as you can see in the upcoming pictures, our roof is a green roof system. Our windows are Passivhaus certificate. Of course, we will talk about the challenges that we have, so that this is all an example to each of them. It's a very good news. It's a very fresh news, so that there is a Turkish window company has a certified Passivhaus window, but this is very important for people to have this. It is quite important because while we are having this building, we waited for 6 weeks for windows to be imported to countries. So they are very qualified systems. So they are triple glaze systems, glass systems. However, there was a due date in that, and because when you give it this measures about this, you have to give the certain measures with the air tightness. in TR54 presentation, the window company will share very detailed information with you. So there's this advantage of this, we can find our product in the national scale in a for a better price, and of course the date, the deadline is lesser. And I believe that this will not be only the window system. Most of our construction materials will have the Passivhaus certificate, so that for zero energy building, they can be more accessible for everyone. I can continue. We have the systems, and of course there could be different sessions, but I always give the same example. This is very important and exciting sunny day for us. The equipment that the now there's the blowing test equipment. Of course, we in the systems, the blower for test wasn't there. We invited a team from the airport, and the equipment was lost in the luggage. We increased their days, and their equipment was found, and they came into work, and they said that you are making a Passivhaus, a Turkish style. That there was this to us, and of course we believe that we did everything according to the project. And there was a Turkish test was made, and you know that you wouldn't pass the first test, and of course these structures go through field tests, and you have to take some other measures, and you can have this. Of course, we were very nervous, and they made the building into test, and of course, we closed all the doors, and also they gave 50% Pascal pressure, and they looked at it with 0.51. We passed the test of tightness, and we said that yes, we said yes, it's a Turkish style Passivhaus. So we were very proud to have this, rightly proud to have this. And for the people who do not know the Passivhauses, I want to show this, and also there is the ecological, the tightness bands are implemented differently in the junction of the window and the wall, corner of the wall, and we think, thank goodness, we passed the test without any problem. As you can see the other facade, other layer insulation, and you can see the green roof. This is another story. We are trying to have the Passivhaus, and we are trying to have the green ones. So we went to UK, and we did it together with Passivhaus, and I couldn't find this solution there, and after that he gave me his email address, and I drew some of the sketches myself, and as you can see, there was a shading element. This was integrated. So regarding that, the detailed solutions were given, and my biggest fear is that there was a leakage on the roof. Since 2004 we've been operational. It has been 7 years, and in 7 years there hasn't been any leakage from our roof. And I was afraid that if there could be a damage of insulation, but there wasn't any problem regarding that. And for the sun breakers we use, because as we can see it, you can see the pillars are there in the facade, but however, there is no need for a shading element.
So it is not only energy saving, which is important, and also using water efficiently, which is very important for us. So in our roof and also in the landscaping of the building, we chose endemic plants which consume water less than other type of plants. So we have green, which also produces oxygen, but we also have these plants which consume less water. This is the front facade of the building. As you see, it benefits from daylight at a maximum level, and we reduce the heat workload even in winter time. It is one of the key lessons of the ecological architecture, and it is also about the issue of shadowing, because if we are talking about building which are only one store, etc., we have this type of plants which can serve as natural shadows. So that's the picture. As I said, it is natural light, and also it reduces the heat workload in winter period. And we also reduce the workload. And we have this storing system to collect rainwater, and after we use this part and this extra rainwater, we take it to we use it for landscaping, and if it's gray water, then we use it for reservoirs, and we use it for reservoirs. And the ecological building tells itself that was the project, and when you enter into the building and if you read the equipment, you read what is the function of this equipment, or you read and it tells its function. So we tell the story of these equipments, and we save the water consumption up to 65% per year. And we have the ventilation equipment for heat recovery, and it is integrated with the underground system. I can give you some examples. As I said, while I was talking about Gaziantep in the beginning of my presentation, I told you that it is hot in summer and it is cold in winter, and it reaches 40 Celsius degree in the summer. And this 40 Celsius degree can be ventilated with a small ventilator, and it ventilates, and when it reaches the climate air conditioning unit, then it becomes 15 Celsius degree. That means we do not decrease it from 40 Celsius degree to 50, but it is 25 Celsius degree to 12 degree, 15 degrees. So in winter it is 0 Celsius degree, and then we use it for the heat purposes. So we keep it 24 within the building, but we do not heat from 0 to 24, but from 15 to 24. So we use this system, which is called Canadian Canal, and we save energy here. In this interior enlightening system, which we use it as the LED energy, which consumes less energy, and we get optimum benefit from daylight. And we also have this LED lighting system. And I'm about to finish. I just wanted to show that this landscaping does not create any pollution in terms of lighting. And we use this type of systems. We try to use local materials, for example, this basalt stone, which you can easily find in Gaziantep, and we use some materials for decorative parts. Even these decorative materials from Gaziantep, we use this copper slab. In this building, so far, we hosted about 200,000 people. It hosted several events. For example, the EU Climate Action Week was held there, and then EU minister was there, and we also worked on energy efficiency. I will show you some children in my next slide. Our objective is to realize these type of buildings and to show that it is not impossible to have these type of buildings. And you see it is the summer school, winter school, and also we have some children on the basis of appointments, and you can see some events. These are natural materials, and we use them to have all these events, and we make presentations. Thank you all for your patience, and I'm happy to answer your questions if you have any.
Points in your presentation. We saw that localization is very important for costs and the lead time. So my question is for both of you. What are the challenges for dissemination of these passive house buildings for public building? We have two different countries and three different examples in this session. So are we living the same similar challenges, or are they different? So vision is very important. We see the local government's visions are very important. So what do you think about the challenges for the dissemination problem? Who want to start? Francesco, do you want to start?
I'm thinking about.
Okay.
Not so easy. Not an easy question. Actually, these are for sure pilot projects, showcase projects, which can really serve as an example for the community, even driven by private guys and private investors. That's also important for the whole community. And but actually, okay, the European directive already stated that from 2021, all private as well as public buildings already since 2 years should reach the NZEB level. But NZEB, according to my opinion, even though that might be better than the existing building stock, on the other hand, is far away from what can be called energy efficient building. So we should really strive a lot to convince the municipalities to invest on the renovation of the public buildings, really like a private person, because in these very two cases, so public buildings and residential, let's say, the home keeper keeps on paying the bills. It's not like an investor who does the building and then who cares about bills. In that case, the home keeper still keeps on paying the bill, and that's very important for the whole community. On the other hand, whereas while for a private person, the investment can be easier from one side because maybe he or she has money to invest. For public administration, at least in Italy, they should store somewhere and stock there for several numbers of years the money to be invested on that project, which means even though there are some national incentives or something like this, some fundings which can come from somewhere, they should really like freeze this money for the whole period before, so until the money for the financing come. And that's a big problem for the administration because then they suffer of liquidity. No, they don't have cash flow, and it's very important for us technicians and designers to support the municipalities. Besides them, support them also in writing down the tenders and so on, orienting somehow the design towards very high efficient buildings. But on the other hand, also giving them support either by putting them inside some European projects or something like this, which can help to recover some funds, how to come to the end, because they really suffer of this liquidity problem.
Yeah, thank you very much. It is very important, you know, the renewables are supported like the same. So in Turkey, in the last 10 years, the renewable energy usage is very disseminated. So it is only as a result of support mechanism of government. So maybe for the buildings, energy efficient buildings, especially for passive houses, it must be another way for dissemination. I totally agree with you. Seda, you faced many challenges during your construction. So what do you think about this topic?
Aslında biz
In fact, we as the local administrations or the central government in Turkey should take a step to renovate, to transform the public buildings. But as I said in my as I was going to say in my presentation, since we are an association, since the awareness is raising very slowly, we need to work harder, but we receive many applications from public buildings, and I think that we will have positive news in the future, and it will be a better situation. Governments need to take a leading position, and it also demonstrates the feasibility of these projects. When it is done in the public administration buildings, it gives a message that these projects are feasible. As I said in my presentation, I shared my experience, what can be done, what were the challenges, etc. I think that the path will.
So I really thank you, both of you, your valuable presentations. As you said, Seda, as CEPEV, we carry out many activities in order to expand the Passivhaus standard in all buildings in Turkey. So I would like to thank everybody who contributed to this session and also this event. And thank you very much. Bye-bye.
Thank you to you. Bye-bye.